Okay, our topic for today is about the horizontal alignment of the road. So, say horizontal alignment. So, as by definition, the horizontal alignment consists of straight sections of the road known as tangents connected by the curve. So, ibig sabihin, meaning to say, you have two roads here which are considered tangents, thing like that. So, you can consider this similar to like a tangent or to a center line of the road. So, as by definition, consists of straight sections of the road known as tangents. And we can consider this one as tangent 1 and this one as tangent 2. Okay, then connected by curves. Connected, let's use other color like green maybe. Thicker one. Okay. So this starting point and this is the end point. You should connect it by the curve. Okay, so that's an horizontal alignment. So, meaning to say, there are old roads or there are like a street there that you will just make the transition smoother. So you will construct a road which is a simple one. So the curves are usually tangents to the circles. So tangent to the circle, meaning to say, these are the segment. These are the old roads where you will construct a simple curve. That will provide a smooth flow of traffic. Bakit ba? So why do we need to put the simple curve on the intersection of two tangents? Why is it? Why are we going to construct a simple curve or a curve instead of this 90-degree straight road? So the main reason is for a smooth flow of traffic. So the main reason is smooth flow of traffic. Because if you will not construct or you will not have a simple curve here, imagine you're driving from here going to there. Okay, then you will have a 180 turn just to go in this place. So it will be better if you will have a smooth transition when you're driving from here. Then you will have a smooth transition going there to the another point. So let's erase this one. Okay, so given that situation, we can say that this is the start of the tangent and this is the end of the tangent. So it is called horizontal alignment, or one of there are different types of horizontal alignment. The design of horizontal alignment entails the determination of minimum radius. So the question will be, what is the minimum radius when we are going to construct this type of curve in a road, on a road? So what is the radius? So you need to determine the minimum radius, the minimum length of the curve, this one, the minimum length of the curve, the computation of the horizontal offsets from the tangents to the curve to facilitate locating the curve into the field. So this one. Is called offset. Okay. In some cases, to avoid a sudden change from a tangent with infinite radius to a curve of finite radius, a curve with radii varying from infinite radius of circular curve is placed between the circular curve of the tangent, such as a curve is called the spiral or transition curve. There are 4 types of horizontal curves. So we have 4 types of horizontal curves. You have number 1 is the simple curve. Which by definition is just a very, very simple curve. So the next one is the compound curve. The third one is the reverse curve. And the fourth one is the spiral or transition curve. So simple curve is just a very simple curve, like you'll connect two tangents by one curve or by one arc or segment of circle. Compound curve means there are two simple curves connected to each other. Reverse curve is composed as well of two simple curve, but the one is inversed and inverse position. So if I will draw this one is the simple curve, this one is the compound curve. Two simple curve but different radius. It's compound curve. The reverse curve will be something like this one, and the transition curve has different types of curve connected to each other. For today is we will determine this one. What is the minimum radius of horizontal curve? Okay, so what are the elements in order for us to determine the minimum radius of horizontal curve? So let's start with analysis of a car on a roadway on a curve. So for example, let's change this color to similar to, say, brown colors. Let's choose brownish color. Okay, let's say this one is color, this one or this one. Okay, so imagine you have this one. This one is an exaggerated view of roadway banking or cross section of roadway. So this is an exaggerated view. So that's a pavement. If you will put some extra design, so these are the base curves. So let's put some elements. This one is inclined at angle alpha, and let's make a car which is color, let's say color blue. So consider this one as a car. Okay, so consider this one as a car driving on a roadway. That's kind of exaggerated actually. If you will have a car there, meaning to say it has its own weight. So let's put a color here. So this car is a weight. So if you consider this one as the center of our car or a truck, so it has its own weight. Okay, it has its own weight. One more thing is when you're turning, the tendency or the moment of inertia or the tendency of your car is to go there, to go here. So this will be the direction of your car. So that's the centrifugal force. Centrifugal force pushing you. So if there is centrifugal force going here, meaning to say the action of your friction is opposite to that. So this one is your frictional force. Okay. Apart from that is you have the centrifugal force. This is the centrifugal force. Let's say this one is F, or F is equal to centrifugal force. Okay, so that's the forces acting on that. Considering the highway has a friction and not lubricated, which is the standard when it comes to the highway. So this one is the angle of inclination of the what do you call this, the highway. And with that you will have this what we call the super elevation, which is letter E. Consider this one as 1 and this one is alpha. Okay, with that there are some things that you should consider. There's a weight here, and if you will like consider this one as x-axis, and this one is y-axis. So with that I'll be able to determine the components of your forces. So you have something here which is W Y, and you have here which is W X. So if this is alpha, this must be alpha as well. So meaning to say WY is equal to W cosine alpha. WX is equal to W sine alpha. Okay, your frictional resistance is if you will remember, frictional resistance is equal to mu n, where n is the normal force, and the normal force should be perpendicular to the surface. So you will remember, normal force is perpendicular to the surface, and it must be perpendicular to the surface. And with that definition, the normal force is the W Y. So meaning to say, frictional force is equal to mu times W Y. Mu is the coefficient of friction. Then so we have that already. Meaning to say, FF is equal to mu. Sorry for the color. You need to make it color WY. Okay. Let's solve for the centrifugal force. Change color. Let's make it color violet. Okay, centrifugal force, F is equals to mass times acceleration, as we will always remember. That's standard. Then if you will remember, weight is equals to mass times acceleration due to the gravity. Then m will be W all over G. The acceleration in a curvilinear motion, you can derive this if you want. It was discussed on physics time. So acceleration due to gravitational acceleration, acceleration in a curvilinear motion is v squared all over r, where v is the speed or velocity, speed of the car, velocity of the car, or r is the radius of the curve. Okay, so with that, let's substitute. F is equals to mass times acceleration. F is equal to W all over G times V squared all over R. So that's it. So F, or centrifugal force acting on a car, is W V squared all over G R. So that's it. So if we'll put it here, this will be what's the color? Color violet. W V squared G O R. Okay, so let's do the checking the equilibrium. So considering equilibrium forces, summation of forces along x-axis is equals to force or centrifugal force. So meaning to say, centrifugal force is equal to frictional force plus the component of weight, which is Wx. So frictional force, or centrifugal force, sorry, is equal to mu Wy plus Wx. To simplify this one, this is W cos alpha plus W sine alpha. So this one will be your working formula, and your okay, so we have something to remember, and this must be a component as well. So if this is alpha, this should be alpha as well. We cannot directly consider the centrifugal force as it is when you're doing the summation of along x-axis, because of it should be along the x-axis as well. So this one is f of x, wherein f of x is equal to centrifugal force cos alpha. Am I right? Yeah, centrifugal force cos alpha. So if we will substitute this one, so this will be f of x. This is this one, because it should be along x-axis, and this f is not along x-axis. So if we will rewrite, sorry for the confusion, so f of x is equal to mu times W cos alpha plus W sine alpha. F of x is equal to W V squared all over R cos alpha is equals to mu W cos alpha plus W sine alpha. Then you can multiply it by W all over 1 all over W cos alpha, sorry. Then the working formula will be V squared all over GR is equal to mu plus W, no W, sine all over cosine is tan alpha. Okay, Then if you want to get the formula of the radius r, so all you have to do is like v squared all over g. Yeah, v squared all over g times mu. Sorry. Sorry. Yeah. Plus tan alpha is equal to r. Okay. Then considering your this will be your working formula or the working radius, minimum radius of horizontal curve, but unfortunately you should consider this super elevation. So with this, let's bring this here. So if this is e and this one and this is something like that, so considering the relationship TOA, tangent alpha is equals to opposite, which is e, all over 1, then e is equal to tangent alpha. Meaning to say, you will substitute this to here. Your working formula will be r is equals to v squared all over g times mu. Sorry. Plus e. So this one is working formula. This one is the minimum radius of horizontal curve. So you should not go below here. Like for example, if your minimum radius is 100 meters, don't do like 90 meters. No, so, because this one is minimum. You can go further, but lower than that is not. So your working formula is r is equals to v squared over g times mu plus e. Okay, let's define. R is the minimum radius. V is equals to speed or velocity. G is the acceleration due to gravity. Mu is equal to coefficient of friction. And E is equals to super elevation. So R is in terms of meters if you're using metric, or if you're using English, it must be in feet. If you're using speed, meters per second, feet per second. Then acceleration due to gravity is meters per second squared or feet per second squared. 9.81 and 32.2. Coefficient of friction, so it's varying. Super elevation is in meter. So that's the working formula when it comes to the minimum radius of horizontal curve. R is equals to v squared all over g times mu plus e. So we derive this formula using this working diagram. So I hope you understand it. It's very easy. It's just F is equals to summation of forces along x is equals to ma, we think newtons. So that's the minimum radius of the horizontal curve. So I hope you understand something. If you have questions, please let me know. I will also send the copy of the PDF of this worksheet to the link below, and you can just download it if you want. Thank you.